Hello students. Today learn the magnetic properties of solids. Solids have electrons. That electron orientation is discussed today. Orientation of electrons in solids. Thus electrons arranged in paired electron or unpaired electron. That is known as a clockwise direction and anti-clockwise direction. Thus, electron paired or unpaired as clock anti-clock. Basically, solids have magnetic properties. Thus, magnetic properties basically dividing on five types. The first five types. First one is known as a paramagnetic. First one is paramagnetism. Second one is diamagnetism. Third one, ferromagnetism. Fourth one is antiferromagnetism. Fifth one is ferric magnetism. Five types. First one, paramagnetism. In this paramagnetism, that solids then applying of the magnetic field. That magnetic field can solid can attract the weak attraction by magnetic field. Then applying of the magnetic field, there has a weak attraction because in the solids one or two unpaired electrons present in solid. One or two unpaired electrons present in these solids, they can that is known as a paramagnetism. Show the paramagnetism. In this one, remove of the magnetic field. In this paramagnetism, to remove the magnetic field, this solid lost the magnetic property. Lost the magnetic property. Then example, Cu plus 2 cuprous ion O2 oxygen. Second one, diamagnetism. In this one, diamagnetism, the solids can applying the magnetic field, that is a weak repulsion field in magnetic field. Weak repelled field in magnetic field because in these electrons have paired electrons in solids. In the solids has electrons are the paired. So paired electrons though has no attractions, always repulsion. Always repulsion. Example is known as H2O NaCl. Third type of magnetism is ferromagnetism. Ferromagnetism. First taking of the solid. Solid is known as one of the metal. Thus metal can loss of one electron M plus and E minus. This can write off the positive charge and negative charge on the solids as a metal. This can write this way. This way. Thus electrons can rotate on the surface on the solids, can move the all directions. Move in all directions. That all directions of the solids. Then applying of the magnetic field because this all direction of these arrangement is known as a domains. These domains that write of the electrons in the all direction this way. Right of the works right of the electrons in moving of the all direction. No perfect direction. So in this particle, then applying of the magnetic field, then electrons are turned into single orientation, single direction. That's one is known as this solid is known as a ferromagnetism. Then applying of the magnetic field, this is a ferromagnetism. These always solids are remove the magnetic field, it can act as a permanent magnet. Permanent magnet. They can write of the examples is iron, cobalt, nickel. This is now as a you can known of the examples. Next one is known as a antiferromagnetism. In this one, domains, then applying of magnetic fields. In domains have negative terminal particles, electrons. These electrons, domains before of the magnetic field. Then applying of the magnetic field. Every electron filled with of the parallel and anti-parallel arrangements. Parallel and anti-parallel arrangements. So this is known as antiferromagnetism. Third one is a ferric magnetism. In this one also domains are arranged in magnetic field, certain as parallel, certain as anti-parallel. So thus electrons are parallel and anti-parallel unequally filled. Thus one certain is exoparallel, less is known as anti-parallel. Two is parallel, one is unparallel. One is parallel, one is anti-parallel. So this one is a weak attractions also there. So this is a weak magnetic field.